Hi, I am Dr. Faiz Ahmed. Today we are going to cover the vectors operation, and it's again introduction to electrodynamics. This is chapter 1, section 1.1.1. And before going to define the vector operations, we have to define what is the vector. So vector is, or are the vectors are the quantities which have magnitude and direction, like velocity or displacement. So we need to describe velocity, how much velocity is in which direction. So you need to define two things, and those two things are magnitude and direction. But for scalar, we don't need these two things. We can describe a scalar with a single quantity, which is magnitude. And magnitude for a mass, we don't need to define the direction. We say like 2 kg of something. So its mass don't have a direction. But for velocity, we have to mention a direction. So those quantities are called the vectors. In vectors, we represent vectors in bold letters, but here describing or writing a bold letter is a bit difficult. So we will be representing a vector with arrowhead on it. And for a vector, the magnitude can be expressed in terms of mod, and direction can be expressed in terms of unit vectors or unit vector of A. And unit vector is a vector with unit amplitude or unit magnitude. So a vector is the combination of a magnitude and a unit direction. Unit vector which describe the direction of the vector. So geometrically we can represent a vector with arrow. So here we have a vector A, so this is vector A. And similarly, we can do the operation on the vectors, like we can add the vectors, we can subtract the vectors. So if we have vector minus A, that means is a vector with magnitude same as vector A, but opposite in direction. So operations, we can start with addition. So we can add two vectors, addition of two vectors. So let's say we have two vectors, vector A and B. So in abstract notation, say we have sum C, which is the sum of vector A plus vector B. We can add the vectors geometrically. So we can use the head to tail rule to add the vectors. So if we have a vector A, so this is vector A, and we have other vector, vector B. So if we want to add them geometrically or graphically, so we have to place vector A here, then put the vector B from the tail, and joining the tail of the resultant vector to B is C is equal to A plus B. So This is called the head to tail rule, and for addition of the vector is commutative. So it doesn't matter if you add a plus b or b plus a, the result will be the same. So addition of two vector is commutative, and also addition is associative. So if you have three vectors, say a plus b plus c, so it doesn't matter which two vector you are going to add first and then the third one, the result will be the same. So if we add b and c first and then add a, the result will be same as if we add a and b and then add c. We can do the subtraction of the vectors as well, and subtraction if we have two vectors, so vector subtraction. So you have two vectors, vector a and vector b, and we want to subtract vector b from vector a. The resultant vector is, in abstract notation, is a minus b. So geometrically, say you have vector a, this is vector a, and we have vector b here. So vector minus b is the same magnitude as vector a but in opposite direction, so it will become minus b, or you can write this one as a plus minus b. So geometrically we have to put vector a there, then we have to bring vector minus b, so minus b will go here, minus b, and the resultant vector will be c is equal to a minus b. Alright, vector addition and subtraction is simple, but the vector multiplication is not that simple. So we can define vector multiplication in three different ways. The first is multiplication by a scalar. So we have a vector a and we have some scalar number alpha. So multiplication of scalar is very simple. So you have some other vector, say b, which is just multiplication of a scalar number with vector a. This is just a number multiplication, a scalar number.